In Unit 3, we're going to be talking about a lot of different types of functions, and you've seen most of these before. The first function is linear. We know that because it is a line, and it can be represented by y equals or f of x equals x, where there is an exponent of 1. The second function is a quadratic function. And just like we call this a line, we call this a parabola. The third function is a cubic function, and that is because it has x to the third power. Third, or 3, is another way of saying cubic. Quadratic had an exponent of 2. Cubics have an exponent of 3. So it could be represented by f of x equals x to the third. Our fourth function is a square root function. Our fifth function is an absolute value function, which you learned in 9th grade, where nothing can ever be negative. And then our sixth function, which we have touched upon in 8th, 9th, and 10th grade, is an exponential function. And we know that it's exponential because our variable is in the exponent. It's the only function where we have a variable in our exponent. So now we're going to talk about the vertex form of each of these functions, or at least for a few of them. So the vertex form of a function is a form that shows us the vertex. So just like we have y equals mx plus b, we call that the slope-intercept form of a function. And ax plus by equals c, and we call this the standard form of a function. These both create lines, they're just in different formats. It's the same for every function. So this week we're going to be focusing on something called the vertex form of the function, and it's super similar to the slope-intercept form. It's similar because in slope-intercept we can see the slope and the intercept, which is why we call it slope-intercept. In vertex form we can see the vertex. So the vertex form for a quadratic is f of x, or y, equals a times x minus h quantity squared plus k. The vertex is going to be h and k. And remember that the vertex of every function is just the tip of where the function is, the highest or the lowest point of the function. So this allows me to see the lowest or the highest point of our function, which is h and k. The vertex form for a cubic function is f of x equals a, notice that they stay the same, x minus h quantity cubed plus k. So the only difference between these two functions or vertex forms is the fact that this has an exponent of 2, which means it's quadratic, and this has an exponent of 3, which means it is cubic. The vertex form for a square root function, you might have already guessed, is f of x equals a, and then instead of parentheses, we're now going to use a square root. Square root of x minus h plus k. Make sure the plus k is outside of the square root. For an absolute value function, instead of using parentheses or a square root, we're going to use the absolute value sign. So we have f of x equals a absolute value of x minus h close absolute value plus k. And for exponential functions, we're going to skip that for now because we don't really focus on how these translate, but it would be very similar. So the vertex form of every function is going to have an a, an h, and a k. AHK, AHK, AHK. A we're going to talk about in a few days. This is the number that determines how tall or how short a graph is. H and K are going to tell me where the vertex or the starting point of each graph is. And we're going to be going into much more depth about how to find these things out.